And now for the next step in our prediction, I've replaced the laser with a green one. And this one, in fact, I don't even know the wavelength of this one because it's scratched out so much I can't read it. So what you're going to do is use the calculation from the red laser. So you would have used the wavelength of the red laser and the spacing of the dots on the screen to work out the distance d between the slits. So now I'm going to use the same grating and we're going to measure the new distance, and you're going to use that to calculate the wavelength. Hopefully it will be something that is in the green region. And you can see here, I think it's showing up much more nicely than the red did, that we have new spacing between slits. Sorry, but new spacing between the dots on the screen. And just quickly measuring it now, if that is at the 30 mark, this is 30. This one is at about 44, I would say. So from 30 centimeters to 44, actually 45.4, 45.4, 30. So you should be able to calculate the new wavelength. And just to show you so that you can see even more clearly, this is the middle grating. The one with the wider lines makes more closely spaced dots on the screen, and the ones with lines closer together means that the dots become spread further out. And in fact, this leads to an important point when it comes to a technique they came up with to actually look at the spacing between rows of atoms in a solid. And that was called, it's a kind of diffraction, that's called X-ray diffraction. And the reason is, you notice as the lines get closer and closer, the pattern becomes more and more spread out. What if we wanted to look at lines that were really, really, really close together? You would need, in fact, you would have noticed that going from red to green, the lines have become more closely spaced. So if I want to look at lines, or things at least, that are really, really close together, without it being spread out ridiculously wide that I can't see it, I need to go to really, really short wavelengths. And that's what they did to look, in fact, at the regular pattern of atoms in a solid. And so they actually went to X-rays, extremely short wavelengths that are, in fact, in the same order of magnitude as the spacing of atoms in a solid. And they used X-rays and a solid, very flat piece of solid, and they looked at the rows of dots, the pattern of dots that came off, and used the spacing between them to work out the spacings between atoms. That's something you'll look at in some calculations. So I'm actually going to get you to use that equation. It's called the Bragg equation, and you'll be working out spacings between atoms in a crystal.